We're going to go ahead and talk about chords more specifically, and we're going to talk about when two chords intersect, talking about chord lengths here, okay? So the first thing we're going to do is remind ourselves what a chord is. It's going to be a segment with both endpoints on a circle. So a segment with both endpoints get ready to pause it on the circle, because I'm going to keep moving forward. Make sure you get that written. We're going to identify a chord in the given diagram. Here we have segment CD, but we also have segment AB. Okay, segment OE, I think it's supposed to be an O at the center, is only the radius, so it's not a chord. It has to be on that circumference. Segment AB can also be called a chord. And we're going to put in parentheses, a diameter is also a chord. Okay, pause it and get that finished. So now we are going to name a circle can have more than one chord drawn in it. So when we talk about when two chords intersect, they're going to look like what you see in this picture right here. Okay, so we're going to name these two chords. And it's simply just going to be segment AB and segment CD. The intersection is going to create four smaller segments, and we're going to use different colors. Go ahead and pause. I forgot to mention this. Go ahead and get four colors. We're going to color each one differently. Okay, so pause. Go get four colors. So we're going to name each one of these four segments as well. So here, this chord AB, is split into segment AE right here. Then I have on the other side of that segment, I've got segment EB. With the other chord, I have segment DE. And then the other side, I have segment EC. All right, get caught up if you need to. When two chords intersect, you're going to have another formula. I told my students like crazy this semester is a bunch of formulas. Again, you will be given the formulas. So I'm going to use the same colors, just kind of write my formula out here. But what it is, your formula is just part times part equals part times part. So you're going to take the one part of one of the chords and multiply it by the other part of that same chord. This will then be equal to, now we're going to go to the other chord and multiply its two different parts. And that's why I want to do the different colors here. Okay, I'm going to drop off the different colors after the first example here. So using this formula, we'll go ahead and take a look at this, and we're going to check the formula and check to see if x is 3. Let's prove this. So what we're going to do is we're going to plug in 3 for x, and we're just going to multiply part times part and the other part times part. We're going to see if they come out to be the same thing. What I mean by that is the first part is going to be right here, 3. The next part, and you have to stay on that same chord, is going to be right here, 15. So 3 times 15. And we're going to set that equal to the other two parts here. 9 times the 5. When we multiply both of these out, 3 times 15 is going to give you 45. When we look at the other side, 9 times 5 is also 45. So, yep, we have just proven that this formula works. So let's go ahead and take a look at a few other examples here. First one we have, we're going to solve for x. So we're going to do our part times part equals part times part. So I'm going to start off with the chord that has the x and the 4. I'm going to do x times that 4. Set that equal to the other chord's two parts, 5 times 8. It does not matter what order you multiply these in, 5 times 8 or 8 times 5. It comes out to exactly the same thing. Okay? Then whenever I do the multiplication, 4 times x is just going to become 4x. That's all it does. They just squeeze together. This will be equal to 5 times 8 gives you 40. And I'm not going to worry about pausing. This is very, very quick. Divide both sides by 4. X is going to become 10. Next one, the same thing, part times part. So here I've got the x and the 15 is 2 parts. So I'd have x times 15 equal to the other chord. The 2 parts are 10 and 24. So 10 times 24. We go ahead and multiply these. We get 15x, just slip them together. And then 10 times 24 is 240. Again, a real simple. Divide both sides by that 15. And 240 divided by 15, going to wind up with 16. Now the next one's going to get a little more complicated, but you need to know how to do this. We're going to have some distribution going on here. All right? So with this one, I'm going to go ahead and break it down with the 2 different colors. All right? If I have this x minus 5 and this 21, I know I'm going to have to multiply them. What I'm going to do is I'm going to put the 21 first, because I'm going to have to distribute. And I'm going to put the x minus 5. That way I can distribute. It looks a little bit easier here. We're going to set this equal to, we're going to have this 24 times that x minus 9. So we want to make sure we distribute both sides correctly. So we're going to do 21 times x is going to give us, use a completely different color here, 21x. And then 21 times 8, negative 5. It's going to stay as a subtraction. This is going to get you 105. We set this equal to, we're going to distribute that 24 to the x, giving us 24x. Then we are going to distribute it to the negative 9. So we're going to get a negative 216, which becomes minus 216. Again, this is where I'm going to tell you to pause it. Move your variables to one side, your constants to the other. Get x by itself. Please pause it now. All right, so here's your final answer. Now, you may have seen something a little funky go on. We end up with, you should have had a negative 105 by itself on the left temporarily before you brought the 216 over. Or, had you decided to move the 24x instead, you would have had a negative on one side that we were able to get rid of. But here's the solution to this problem, and that is what happens when chords intersect and how to find lengths